Hi, mathletes. You are going to be graphing equations with tables. And after this video, you will be able to create a table given an equation and then plot those points to make your graph. Graph the function below by completing the table of values, then plotting the points on from the table. So we have this equation, y equals 4x minus 1. We're going to see what values we get here by plugging those in. So we're given x values. We're going to evaluate the expression here and solve for y. We're going to talk about what type of function this is and why, and we're going to find the rate of change using the table like we did in the last unit. So just like we did in our opener, we have to replace the x value with the given x values. That's what we're looking for. So everywhere there is an x, we're going to substitute the given x value into the equation. So here we have 4 times x minus 1. So our x value in this case is negative 2. That's order of operations tells us we do multiplication before subtraction. So that's 4 times negative 2, which is negative 8. We still have that minus 1. Negative 8 minus 1. Again, think of that number line. You have a number line built into your x's here. Like we could look at, we have negative 8 and we are subtracting 1. So we're going 1 to the left. That's going to be negative 9. So what we have here is the y value is negative 9 if the x value is negative 2. We can write that as an ordered pair here. And I would like you to do that, negative 2, negative 9. And we can plot that point right now if we want to. So negative 2, negative 9 is down here. And that is our first point that we plotted. We're going to now take a look at the rest of the table. So we need to plug in the x values at each row. So for the second row here, I have x is negative 1. So I would plug that in. 4 times negative 1 minus 1. In the middle row, I have 4 times 0 minus 1, 4 times 1 minus 1, and 4 times 2 minus 1. And you're going to go through and simplify that using order of operations. Hopefully you got ordered pairs that look like mine. When you plug in negative 1, you got negative 5 out. When you plugged in x was 0, you simplified and got y was negative 1. When you plugged in x was 1, you got y was 3. When you plugged in x was 2, you simplified and got y being 7. So you can plot these points if you haven't already done that. And you can see our points here all look like they're lying in a line. Let's double check looking at our rate of change to see if that matches. So anything that lies in a line we know is linear. And normally we would say rate of change is constant. And you can see that rate of change in the table because we are going up and over the same amount each time. We haven't looked at it that way before. We've looked at it in our table, and we can still look at it in our table. We can see that the x values are increasing by 1 here. And when you look at your y values, from negative 9 to negative 5, and again, if you're not seeing that, remember you can look at your x and y axes as a number line. You can see that it is increasing by 4. If I look here from negative 5 to negative 1 is also increasing by 4. And from negative 1 to positive 3 is increasing by 4. And from 3 to 7 is increasing by 4. And so we know that the rate of change is 4 over 1. And you can see that how it plays out in the table and how it plays out in our graph. Let's connect those lines, those dots with a line. So we're going to continue to graph our functions. We are going to first complete the table. And to do that, we have to replace the x value in our equation with the given x value for each row to find the corresponding y values. So we are replacing this x value with whatever x is. So in the first case, it's going to be 0. And then it will be 1, and then 2, and then 3, and then 4. You're going to replace x with these individual values. So this equation represents that we have something, minus 2, squared minus 4. And that something for the first row is 0. And then in the second row, it's 1, then 2, then 3, then 4. We're going to plug all those in. You're going to simplify using order of operations. 0 minus 2 is negative 2. You can look at your X and Y axis over here. These are basically number lines. So if you're at 0 and you have to go subtracting 2, that's to the left 2, that means it's going to be negative 2. And then you're going to square that and subtract 4. Squaring means negative 2 times negative 2, which is positive 4. We still have our minus 4, and that is 0. So our first ordered is 0, 0, and that is at the origin. Next, we're going to look at plugging in 1. When you have 1 minus 2, so right here is 1, and you subtract 2, you end up with negative 1. So in our parentheses here, that simplified to negative 1, we're squaring that, and then we're subtracting 4. Negative 1 squared is negative 1 times negative 1, which is just 1. And then we have the subtract 4. 1 minus 4 is negative 3. And again, if you need to see this, you can look at your x-axis as a number line. So you can look at 1, and if you're subtracting 4, see that you get to negative 3. And so our ordered pair is 1, negative 3. We'll plot that right here. So finish the rest of this table and write your ordered pairs. Take a moment to look over my table and make sure that that matches. Come see me if you have questions. Ask me in class. So we need to plot that third point. So when x is 2, y is negative 4. When x is 3, y is negative 3. And when x is 4, y is 0. So these are the points that are plotted here. Definitely not linear because we don't have a straight line. Let's look at our rate of change by calculating the change in x and the change in y. So when we do that, we're going to do it just like we did in the last unit. I don't have a y column. I made my y column into the coordinates. So we're just going to look at the second part of the coordinate. So for example, from 0 to negative 3, and keep in mind when you're at 0 and you're going to negative 3, you're going to the left, so that's minus. So this is minus 3. From negative 3 right here to negative 1, I'm going to the left 1. And you'll complete your table or your changes in x and changes in y now. You can see that our change in y's are not constant. My change in x is plus 1. My change in y's are changing. And so we need to find the second difference. And so to find the second difference, you're just finding the difference again. We can look, if you're at negative 3 and you're going to negative 1, you're going to the right 2 units. So this is increasing by 2. If you go from negative 1 to positive 1, you're going 2 jumps or 2 spaces, so to the right, which is also positive 2. And then from 1 to 3, if I'm just using from here to here, if I'm just using my x-axis as a number line, I'm going to the right 2 again. So my second difference is constant, so I can write that in my y. Second difference is constant. What does that tell you about what function we have? You can look back in your notes, but hopefully that tells you that this is a quadratic function. The shape should also be a giveaway. And so what we say about the rate of change is the rate of change is increasing by 2. And I just drew in my smooth curve. Remember, quadratic is going to be U shape. So no pointy bottom, it's a U shape.